ways. B, A, C, etc. 6 different ways. With combinations, in many ways, it is only one way. A, B, C is one combination. As in, BCA is the same combination. It is not a different combination.
DEF is a different combination.
Oh yeah, DEF. But rearranging these letters doesn't make a difference. So imagine 3 people are picked for a team. It doesn't matter what way you say the 3 names. They're the 3 people who are picked. So that's just one selection. It doesn't count as 6 different selections because you can put them in different orders. Okay, so that's the main difference. On your calculator, it would have been way easier if you'd known this before we did the starter. If we have to choose any 5 cards from a deck of 52, we can use the calculator. We can use a formula, which is up there, but we can also use the calculator, and there's a 52, there's an NCR button, or sometimes that's the button on the calculator, NCR 5, that automatically will choose 5 combinations out of 52. Or you read that, you see this written, 52 choose 5 sometimes, or it's mathematical way 52 over 5 like this in a kind of matrix bracket like that. You see that. And it uses factorials to, and this formula up here to, where is it? The second one, the one under binomial theorem. N choose or is n factorial over or factorial n minus or factorial, I think. Or, yeah, that's the way I say it. Yeah.
So we don't need to memorize it?
No, absolutely not. It's in your formula booklet. Do not need to memorize it. So this is only used if, yeah.
Is that combination?
That's combinations, yeah. I'm doing combinations now. So that would have helped a lot in the one you just did. Now, on your calculator, I'll show you where it is as well. If you go and get your calculator out and you want to do that card question, 52 cards, and you want to choose 5, press 52 on your calculator first.
How do I do that?
Press 52, it's not too hard.
52.
This is the go. These are not loaded.
So you press 52. I'll show it to the camera. 52. Then go press math and scroll over to the probability one, P or B, and it is the third one down. Is NCR. And then press 5, and you get that answer that we had earlier on. So that's 52 cards. Pick any 5. Is done that way. Choose any 5. And your permutations one is also there, but permutation is probably better off if you do logically with factorials, but it's also there. 50, the NPR button. NPR, and the formula is, in fact, I better not write it wrong. Yes, n minus r. So you can see that this extra r factorial removes the, so when we did the last question, we'll use this one. When we do this C5 versus NP5, there's this extra or factorial we're dividing by, which is dividing by the 5 different options. You see that? That's 5 you divide by 5 factorial because each one of these set of 5 cards is the same. So you divide by 5 times 4 times 3 times 1. You can remove all the different ones because there only is one. That's why you divide by the extra or factorial here. Perhaps that makes sense. Okay. But usually it's the permutations perhaps are the harder ones because the combinations ones very very much maybe logical. All right, let's have a look. Let's do some permutations first, and we might get on to combinations. So let's list the permutations of the symbols x, y, and z when they're taken one at a time. The permutations. So x, y, and z, if you take them one at a time, this might be pretty obvious, but what are they? How many should I get? 3. If I can only take, there's only 3. It's x, y, z, yeah? X, y, z. 2 at a time. Okay, yeah. So xy is different than yx, isn't it?
Yeah.
Yes, because it's a permutation. If there's a combinations, it'll be the same thing. So xy, yx, and so on, xz, zx, and yz, zy. And if we did it 3 at a time, which we could, but it's just this again, but what many will we get? How many? 3 factorial?
Yeah.
So the same number as this?
Yeah, 6 ways.
There's 6 ways? X, Y, Z, you're right. X, yeah, it's just like ABC. X, Y, Z is different than X, Z, Y, and so on. Okay? But if there are combinations, there's only one way of combining all 3. Okay? Let's move on to slightly more difficult questions then. Okay, these are all permutations, so we know that we're dealing with this style of one to start off with. We're not dealing with combinations yet, I think. Have I done it? I think I
Row A, how many different?
okay. Yeah, you're going fast there, yeah? So let's try and logic it out without using the formula for any of these. Let's just try and picture it or logic it out. Alphabet block space, how many different permutations are there? All right. So the first one? 10, you think?
Yeah.
Anyone disagree? I think probably 5 factorial, yeah. Many different permutations.
What is that?
120, yeah. So how many different ways can I arrange this? Many different options. Many different options do I have for the first? If I want to arrange them. This can be A, B, C, D, or E, yeah? If I've picked one of them, what can the next one be? Yeah, B, yeah, whichever one it is. There's 4 options for the second one.
So it's just 5 after.
Yeah. 120. Okay. Let's look at it. How many permutations end in the letter C?
4 factorial.
4 factorial. 5. Okay, we can logic this out without even thinking about formulas. If it ends in C, there's only one option here, yeah?
Also 4 times 3 times.
So how many different options we have for this? 4. There's 4 left over. And then there's 3. And then there's 2. And then there's 1. 4 factorial is correct. What's that, 24? Okay, you're reading ahead. Many permutations have the form something times A times, well, I'm putting in the times. I shouldn't do that. 6? You sure?
Wait.
So if this one has to be A and this one has to be B, how many different options do I have for this? 3. And then 1. Then how many are left? There's 2, then 1, then 1. So there's 6 different options. How many? Think about it. Okay, the last one then. How many permutations end with a vowel A or E? So if they end with a vowel, how many different options do I have for the last box? 2.
And 2 in the beginning as well.
2 here?
No, is it not?
Begin and end with vowel.
Wouldn't you want to just do them separately?
Yeah, 2 and 1. Like, the start would be 1, right? Because if
Oh, if you do 1 with A and E and then 1 with E and A, and then just add. Would the start not be 2 and the
Well, let's do both ways and see if we get the same answer.
so, like, no, the first one has to be 1 because if there's 2 on the other
Yeah.
side, there's only
Or the
one.
other way around, but that works.
Oh yeah, this is the same as that, yeah, because multiplying.
So then you do 3, 2, 1.
So 3 options. You sure?
Is this, am I wrong?
2 at the front? Okay, yeah, you could put 2 here and 1 here, but that's the 2 vowels out of the way, isn't it? If you've used 1 up here, you only have 1 there. If there how many vowels are in the... Just make sure there's only 2, yeah. Yeah? So yeah, if you either way around, you either put 1 here, and then is it 3, 2, 1? Yeah, I think so, yeah.
Wait, so then.
Yes, because you'll have one up. You're saying you restrict it to 1 and 1, and then you'll get that many, and then you end up doubling it. Yeah, yeah, same. Yeah. All right. All right, let's do more logical stuff. There are 6 books arranged in a row in itself. How many ways can 2 of the books, A and B,